You guys, did you enjoy the party last night? I certainly did, although I had to cut it a little short last night because I signed up for the bike ride this morning, which was a beautiful bike ride, but at 5 o'clock in the morning I was not feeling so happy about my decision making when I signed up for it. I'm Owen O'Malley. I'm a co-founder and architect at HortonWorks. I've been working on Hadoop since the very beginning. My first patch went in before it was even Hadoop. And I was the architect for MapReduce and then the architect for adding security. And now I mostly work on Hive and Orc. Please feel free to ask questions whenever they come up. I'm here to answer your questions, right? If I can tailor it to your guys' interests and needs, that's the best. Because I want to make sure you guys get the information that you need. And because I've worked on this stuff a long time, I have a lot of background in what people have been doing. So when you think about security, rather than just say, oh, we need encryption, you really, really want to think about what are the threats you're afraid of, right? Because you don't want to completely throw your usability away, right? Security is always a trade-off of usability versus making things secure. But so you need to think about, okay, what threats am I actively afraid of? What am I afraid that people are going to get access to? And who's going to be attacking me, right? Is it hackers on the internet? That's pretty remote because most Hadoop clusters are buried away inside of your data centers. But those are the kind of questions you need to think about. And of course, part of the approach is that you need to minimize their attack surface, right? You need to give them the fewest opportunities. Just as with most things, the more you expose open, the bigger the problem you're going to have. So, for example, typically people set up their secure Hadoop clusters like this, right? The slaves are, I guess I should use the pointer, all talk to the masters, but unlike most databases, the user code actually runs on those slave machines. So you actually need this to be trusted because it's your users that are there, but you also actually want to really secure the name node and resource manager. So typically people actually put a firewall around the masters, and for heaven's sakes, don't let the users log in there, right? Because that's part of cutting down the surface area. If you don't let them log on to the masters, there's a lot less they can do. Now, because your companies have a lot of computers all over the internet, you absolutely want to put a firewall around your Hadoop cluster. When your security people come to you and say, okay, we need to know every port that's going to be open, that's a really painful conversation to have with Hadoop, especially if you don't know if you're running, because of course you're going to be running HDFS, you're going to be running Yarn, you may be running Spark, you may be running a bunch of other services, and you really, really don't want to have to go through each of the 20-some open source projects and figure out which ports all of them use. So by setting up a firewall and making very specific access points, then your security group will be much happier and you can resolve a lot of their anxiety. Now, because of that firewall, you'll notice that often people set up an SSH gateway to log in so that when users come in, they will SSH there to do their commands. Now, that said, they also typically, if you can see the red lines are HTTP access because you want to be able to get to the status consoles on the masters. And so you actually have holes in your firewall so they can use HTTP. Now, some people are happy with SSH, but some of our customers were like, We don't like SSH. We don't really want SSH. And so we created a project called Nox that does the equivalent of the SSH gateway, but it does it all using REST services. So you use HTTP to get to Nox, and then you can get from Nox to the rest of the cluster. Okay, so where are people coming from? The worst possible case is if they have physical access to the machines. Fortunately, very few companies need to worry about that because they're buried off into data centers. And if they're in a data center, it's really hard to get access. When I was working at Yahoo, for example, we got to go into the data center once to see the machines we had been running on for a year. And we were like, oh, so that's the host that we've been seeing every day for years, but now we can actually see it. But typically, physical access is very, very rare. Now, remote access is if they're in your company's network, but not inside the cluster. Then if they have access to the gateway machines, they've got a little more access. The slave machines, and worse, the master machines. So like I said, you really do want to control access to those master machines to really just the ops teams. Now, who they are on those different boxes matter. If any security vendor says, oh, we can protect you against root access, they don't understand what they're talking about. On every version of Linux, root has access to the memory. Once you have access to the memory on a box, you can see every secret, right? If your process is running and you've got root access, you can get any secret that you want. For example, the Heartbleed bug, that was just getting a random sample of memory, and still it leaked huge amounts of secrets. With root access, you can get anything you want. So you want as few people as possible to have root access. That's, again, part of minimizing your surface area. Now, your Hadoop administrators, they have more power than the normal users because they can see any files that they want. They can see any jobs that they want. So typically, your support team has that kind of access, but they don't have root typically. And then finally, the users have the standard permissions. And so they get the normal, so that's the least threat. Okay, when we started Hadoop, HDFS didn't have owners and file permissions. That worked when it was a small group of people working together. But the first time that one of the universities tried to use Hadoop for a class, you can almost predict what happened. One of the students accidentally deleted /users, which contains all the home directories. It was an accident. They were trying to delete their home directory. They accidentally hit all the other students. That was unfortunate, but soon after that, we got both the trash, which when you delete files, saves them for 24 hours until they actually get permanently deleted. But we also got owners and permissions out of that. Now, at that point, they were still unchecked, right? You could still pretend to be anyone you wanted, but at least accidents didn't have the same kind of impact because there was a safety check to say, hey, you shouldn't be deleting that file because it's not yours, it's your friend Joe's. So that worked for a while. But one of the other issues is we needed isolation between the users running jobs. One user was starting this process tree and they wanted to clean up. They decided to get clever and be nice and clean everything up for us, and so they did kill all -9 Java. That was awesome because when that happened, everything was running as MapReduce, And so not only did they kill all of their processes, they killed the task tracker, they killed their friends, their coworkers, everyone's process. So from our point of view, it basically meant that half the cluster just disappeared. So we were like, okay, we really need to get more isolation in there. And so you really need the Linux container executor. And basically what that does is it runs the task as the user that submitted the job. So that gives you isolation. Now, there are other pieces that are coming in the near future for this. In particular, we are starting to integrate with Linux containers. And so that currently you need to have each of your users provisioned on each of the machines. So you typically use LDAP to make sure it gets pushed across. But with Linux container executor, that's how it does the segregation. If we can, we're changing Yarn so that you have an option so that you run inside of a Linux container using Docker. And once you do that, then you actually don't need those user accounts provisioned, which again increases security and improves isolation. All right. Now, the next piece is that you don't want users coming in from anywhere, or you want to make sure that only the users that are authorized to use Hive are using Hive. Each of the services has a service authorization list that lets you control it, but it's kind of a pain because you have to figure out how to make each project do it. So actually, Apache Ranger simplifies that a lot. It'll go through and you can say which groups are allowed to access each service and limit so that those services will only respond to the right users. This is also where you need the firewall, right? The firewall really is how you're protecting against this because you don't want all 30,000 of your employees accessing your Hadoop cluster. There are certainly counterexamples. Let's see. Facebook, for example, typically runs without firewalls, without Hadoop security turned on, and they just trust their employees to do the right thing. Most companies like the added assurance of turning the firewalls and security on. All right, so another one that often comes up is eavesdropping and watching network traffic. This actually isn't a huge concern inside the data center because to do it, you need to be root. So if someone's got root inside the data center, they already have a lot of access. But on the outside part of the network, it's often that you'll see companies where there are just Ethernet ports sitting around. It's really easy to plug a Linux box in, and all of a sudden, now you have the ability to watch all the traffic that's going by. So to fix that, you need wire encryption. Fortunately, almost all the Hadoop stack has HTTP SSL encryption. You probably want to turn that on because the HTTP connections tend to go outside of the data center. The other ones, actually, I'd recommend turning off unless you actually are worried about people having root in your data center, because they significantly slow down your performance and the exposure is relatively small because people don't typically have root in your data center. But there are configuration knobs to turn it on for shuffle, for the HDFS data transfer protocol, and for RPC. Now, that was good for a while, but then someone pointed out to the security folks at Yahoo that, hey, there's a command line switch that lets you pretend to be anyone you want. Obviously, the security guys weren't very happy with that. It was really handy for us using Hadoop, but it wasn't good for security. So we added Kerberos. Kerberos is a authentication service that was developed back in the 80s. It's very mature, very well designed. It does mutual authentication. So not only are the services guaranteed that it's you that's doing it, you're guaranteed that it's the service. So for example, if you're talking to the name node using Kerberos, you're actually sure that it's a real name node, not someone who's put up a server that's pretending to be the name node. That actually did the vast majority of what we need. The other piece that lets us do is because now that we're sure of what user this is, almost all the tools have an audit log. And you absolutely want to turn on the audit log because that gives you complete details about who accessed what files in HDFS, who accessed, who ran which jobs. It gives you all the details, and actually, even for performance debugging, it's often useful to look at the HDFS audit log to be able to dig down. I've often talked to a customer, and they're like, oh, nothing changed, but our jobs are running much slower. One of the first things you want to do at that point is look at their audit log and see, OK, are there actually more request HDFS going on? And if there are, you're like, OK, look, this has changed, and that's why things are running slower. It's also really handy if there's a security break-in. For example, LinkedIn was broken into at one point by hackers. And the people were worried that they'd gotten access to the Hadoop cluster. Well, by using the audit logs, the admins at LinkedIn were able to show that, no, they hadn't accessed the Hadoop cluster, and so that they were still OK. HDFS permissions, the standard user group other permissions work great. They, if they satisfy your needs, then that's what you should be using. There are actually access control lists that add additional flexibility. One piece that people don't typically know is that there's a user-to-group mapping. By default, it maps to the Unix groups, but in reality, you can map it to whatever you want. So for example, if you don't have the groups defined in LDAP the way you want them, you can actually modify that script to talk to some other source so that you can put people into virtual groups based on their project or whatever. Even if those groups aren't managed by LDAP, you can still provide permissions based on those groups. Right? For HDFS, it'll be like those groups are real groups, and so you can control access. So ACLs are mostly useful if you can't define your own groups, but the user-to-group mapping lets you define groups, at least if you're an admin for the cluster. You absolutely want to set up group directories. Again, that makes sure that people have access to it, and you want to set up quotas per group. And quotas in HDFS are hierarchical, so that if you put a quota on a group directory, then it'll be enforced regardless of who writes down in there. And so you can enforce the quota on the group, and furthermore, it gives you a good place to turn on permissions so that you can control at a single point who can see into this directory, who's allowed to write into this directory, and manage your permissions there. And I highly recommend that you minimize the use of global spaces. One place to be particularly careful is Hive's temp directory. You really, really need to manage the permissions on that to make sure that the right people can see it and the wrong people can't. And actually, even better is splitting up the groups so they have their own Hive temp directory. And actually, I've even seen it done per user. OK, physical access to the machines. First of all, it's very, very rare. But there are great examples where if they can get to the physical box, even if it's an encrypted file system, they have complete access. It turns out that if you lower the temperature on your memory chips, even if you power them off, you can move them over to another computer, power them back on, and get a perfect copy out of the memory. So you need to control physical access, right? If you're running your Hadoop cluster in a spare office, that's probably not a good place. You really, really want it to be in your data center. Now, sometimes people can remove hard drives. That's when you'd want to have the file system encryption turned on. Most large companies just destroy the hard drives coming out. If you ever have bought a computer that's a surplus computer from a large company, they never come with hard drives because the only way hard drives leave their data centers is chopped up into dust. And so that's the best solution, because then you don't have to pay the performance penalty of the drive encryption. But if you are worried about people getting access to the retired drives, then you can turn on file system encryption. All right. So if they're a Hadoop admin, but not root, then one of the common cases is that you don't want them to be able to see the data, even though they're responsible for backing it up. So one of the things that got implemented in Hadoop is Hadoop encryption zones. And basically it says that everything under this subdirectory is going to be encrypted before it's actually stored on disk. So that actually, but fortunately there's still a raw access so that your admins can still copy the raw bytes without being able to decrypt it, so you can back it up to another cluster, even when that backup process doesn't have access to read the bytes because it doesn't have the key necessary to do so. So one of the nice things is each file gets a unique key, and the client actually decrypts the data. So with encryption, of course, the first thing you need to watch is who has access to the keys. And when encryption zones was set up, it was picked so that each zone has a master key, and then each file gets its unique subkey. So when you read a file, you basically say, hey, I need the subkey for this file. And so both, so that if you get a key, you only get the subkey if you need to read the file. So that limits your vulnerabilities from having a key leak, right? Users are never given the master key for the zone, so that even if they've read one file, they still need to ask for the subkey on the next file. Now, not everyone wants to store their keys in the same place, because again, that's a critical piece of infrastructure. And so we created a key provider API, and basically it's a plugin that lets you, as long as you implement that interface, you can get your keys from wherever you want to. And it allows third-party plugins. It has named keys so that you can have different keys for different parts of your system. It has key rolling so that, for example, if you want to have a version of the key and then roll it because you're worried about the security of the last version, you can roll it and the key management system will remember both keys. And there's a key management server that's built into Hadoop. I don't actually recommend you use that one. That one was kind of thrown over the wall, and it's there, but it's not recommended. On the other hand, Ranger has a key management system that has been finished, so you really should use the Ranger key management system. Now, when you're encrypting in HDFS, we had a couple of key requirements. The first was that we couldn't afford to pad everything, because if you start padding things, what happens when someone starts appending is that, oh, now you've got those bytes you appended to pad it out to an encryption block length. That didn't work. The other piece that wouldn't work is if you wanted to seek into a file, you needed to make sure that was still supported, because if a file reader is seeking around in the file, you don't want it to make it start from the beginning and read the 500 megabytes to get back to where it wants to get to. So we used a scheme called AES CTR. It's based on AES. But instead of encrypting the file directly, it takes the key, encrypts initialization vector, as well as a counter. CTR is the counter. And so basically, each encryption block or chunk gets the next number, and then that's XORed with the file contents. And so you end up with a ciphertext, but you don't have to pad. You can still append, and it means that seek is fine because you know exactly what the value of the CTR is at any point in the file. All right, now I'm going to transition a little bit to talk about Hive. Hive has a lot of complexities, and so I wanted to talk about Hive was originally done at Facebook, and so they didn't worry a lot about security. And so basically, every user had access to the database that stored the metadata, and that quickly led to this problem, where every user had the password, and so for people that were worried about security, now people could drop the table, they could make the whole metastore in the database disappear. That's rather unfortunate for people that are worried about security, and so we needed to create the external metastore. So what the external metastore is it basically pulled the access to the metastore out to a separate process, and by setting up that process, now only that process has the password for the database, and everyone else just talks to the metastore when they needed access. Now, even with the metastore though, the metastore didn't have permissions, and so we had the problem that people could still, they couldn't wipe out the whole database, but they could still drop a table that they didn't have access to. And so we created the storage-based authentication module, and basically what that lets you do is it sets the table permissions to match the HDFS file permissions underneath that are supporting the data. That actually does a really good job in terms of making the Hive permissions match the HDFS permissions, and lets you run completely securely, because now the metastore will refuse to do anything that you don't have permission to do in HDFS. So you won't get one of these things like, oh, the metastore said I could do this, but HDFS says I can't. The downside of this is it's hell to manage, because now you need to go through your Hive warehouse and set the owner and group in HDFS to match the people that should have access to each table. So I've got customers that do this, but it's a lot of work. They have to be pretty serious about managing their permissions. So that's what that looked like. All right, that worked, but it was awkward to manage, and it was awkward because you couldn't define some columns that were protected, right? Sometimes you have a table where one column is the person's social security and the rest is open information. So if you want to protect that one column and say who's allowed to access it, there wasn't a way to do it with the HDFS permissions, because the files were all as one unit, and so you couldn't have individual permissions. So we created SQL Standard Auth. That lets you use standard SQL grant permissions. Ranger actually provides a GUI for it. And instead of giving people partial permission in HDFS, you say only the Hive user is allowed to see the warehouse in HDFS. And all the normal users use Hive Server 2. So with that, people connect in from JDBC. It goes to Hive Server 2, and then all your stuff runs as Hive Server 2. So that lets you get permissions at the view level as long as people are willing to go through Hive Server 2. Now, there are some restrictions with that. One of the pieces that we're always very careful with in Hadoop is controlling where user code can run. So if you think about this model for a bit, one of the characteristics of this is that Hive Server 2, because it's enforcing the permissions, can't be allowed to run any user code, right? It has to be just Hive and not user code. So that means this model doesn't work very well if you have a custom input format or a bunch of UDFs that your Hive users need to run. Does that make sense? So I still have people using the storage-based auth because that way they can run the user code because the permissions are enforced in HDFS. So yeah, there's also a concept of of being able to encrypt some columns. But you need support from the file format or a UDF. So column encryption would encrypt the entire column, and it would be file format specific. We're actually working on a patch for ORC that will let you encrypt some columns. And because ORC is laid out with the column split, because it's a columnar format, it actually means that you can actually use different keys for the different columns, and it will automatically work, right? So if you can't read a particular column, you won't get any information about it. You'll just get, okay, there's just complete noise here. You won't know whether it's null, whether there's a long value, because each of the values will get encrypted together. So that is a strong one. Now, sometimes instead of completely masking it, you want to hide the values. So we often see things like customers want to, instead of the user's precise age, they want an age range, right? Instead of saying that they're 27, you want to see 25 to 27. And actually, it's not on the slide. That was my screw up. But Ranger just added functionality to support masking of data as it comes through. And so you get to define rules for how it's masked. There are also third-party providers that provide masking. Now, okay, speaking of those third-party providers, one thing to be very, very cautious of is anyone who tells you, oh, we've got this really secure encryption, it's really fast. Encryption's really hard. People often make mistakes when it comes to encryption, and so anything that doesn't have a lot of review is very problematic. And so encryption systems that use AES or one of the other standard encryption techniques are good, but avoid anyone that's got, oh yeah, I've got this great encryption, it's awesome. For example, in just terms of how hard this stuff is, when we first did Hadoop security, the developer who worked on that piece made a slight mistake. When they specified the key length, they put in 16 because they wanted 16 bytes. Turns out that Java was expecting bits. That meant that all of Hadoop security, until we found that bug, was based on 32K as possible values, not high security. It's easy to make these kinds of mistakes, right? You really, really don't want a proprietary encryption scheme. That's not a good strategy. Okay, if you've got questions, the best place to go is to the developer lists, Common Dev or at Hadoop or Dev at Hive. If you've got security issues, please contact the security list. Now, you guys aren't allowed to join those lists because those are where people report vulnerabilities. But you can send email, and although one word of caution, please be understanding that everything at Apache is volunteers. And so if we don't get back to you right away, it's not that your report isn't important. It means that everyone was busy doing other stuff. So sometimes you need to focus a second time, but please do report any security vulnerabilities that you find. Okay, so that's what I have. I'd love questions. Anything? Oh, come on. Yes.
Just a small question. You said something about user and groups that could be different inside HDFS.
Mm-hmm.
Wasn't clear to me.
Oh, I'm sorry. So the HDFS has a configuration for user-to-group mapping, and that actually is just a plugin. So it defaults to using the Unix groups on the name node, but in reality, you can have it look anywhere you want. And so you can have it look at a company-specific database if there's a better mapping for what your company does.
So then you would not be using the users from Unix at all.
You wouldn't use their groups. It would just use the ones from your mapping. Yes.
Which groups you would, when you implement LDAP, that would be the LDAP?
Yes, by default, it goes to the Unix groups, which then goes to LDAP. So that is by far what most people do. Yes?
You've posted on a whole raft of areas of security
Mm-hmm.
and the various layers of them. With respect to Ranger and some of these products that we're seeing,
Mm-hmm.
do you see Ranger as being realistic to manage these layers, or would we always be delving into various layers of security?
The Ranger project is trying to be holistic, right? They're trying to provide a single pane of glass. One of the places where they can't really be the sole answer is when it comes to authorization, right? Because, for example, if Ranger tries to control the permissions for all the files, actually Ranger will let you do that, but it's hard for them to manage because of the scope, the number of files, right? They can't really handle millions of files at once in their authorization tables. Hive, they can do a much better job because there's a lot fewer objects. Does that make sense?
But if that where Atlas comes in, so Atlas provides metadata for everything that exists out there, correct? Is that the idea?
So yes, Atlas and Ranger are being integrated, and so the direction they're going is to pull everything in. With security, unfortunately, sometimes the abstractions get leaky, and so you need to be aware of what's under the hood. So in a lot of ways, you need to be aware. Like Ranger doesn't actually define how you set up your Hive, other than they actually prefer the Hive Server 2 model, because that lets them control access to columns. But you need to at least be aware of what other things, like you can't have input formats and output formats in user UDFs if you do that. Does that make sense? Yes?
But when you mentioned SED drive having a performance penalty, how would you quantify that?
The performance penalty for which one?
The self-encrypted drive.
Oh, for the drives encrypted down to lower level? I actually don't remember the stats for that. Again, most of the customers aren't worried about people taking drives out of their data center, so they don't actually turn on the drive encryption. I know some of them do, but the ones that do, at that point, they have to look at the vendor, and so I don't know what the numbers are. I'm sorry. Yes?
So the same question, but for encryption zones.
Okay, the encryption zones, the performance penalty, I believe it's roughly in the 5% range. It depends on the different variables there. The details matter. You definitely want the native libraries at that point. Is there another one? Ah, yes.
You mentioned a lot of techniques and ways of security clusters. Just wondering if you have any recommended tools for doing pen testing and doing checks.
No, unfortunately not. that's one of the issues is we need some more. So it looks like I'm out of time, but there's definitely a lot going on in this field, and so definitely stay tuned.